Hello, everybody. My name is Masood Olia, and I'm a faculty in the School of Engineering at Wentworth University. And I'm here with a problem, as you can see, related to the topic of kinematics of particles. And here we're using the cylindrical coordinate system to solve this problem. So we have the arm of this robot, as you can see, which is extending. Let's look at the statement of the problem. Extending at a constant rate of r prime, rate of change of r. So as you can see, r is defined as, where the position of this arm is, as you can see in this picture. And that is the rate of change is constant. So that means actually that at r double prime, which is the derivative of r prime, would be 0, since r dot is a constant. So r dot is given to be 1.5 feet. So this is when r is equal to 3 feet. Okay? So when r is 3 feet, r dot is 1.5, is constant. Because it's constant, the derivative of it is 0. And then we are giving also the height of this grip from this reference line to be 4t squared, changing with time in that form. And then theta, the angle at which the arm rotates, is also given based on that equation. And then what are we trying to find? We want to find velocity and acceleration, magnitude of velocity and acceleration of this point A, the grip A, when t is equal to 3 seconds. Very simple problem, guys. See, we are using, as I said, cylindrical coordinate system. So cylindrical coordinate system is just a three-dimensional version of polar coordinate system. So r theta would be polar. So we add z to it. In this coordinate system, velocity, which is basically the derivative of r, and you can look at the derivation of it. I probably make a video on that. Happens to be, there are three components of velocity. One is the radial component, which would be r dot. So that's the radial component multiplied by the unit vector u sub r. That's the radial unit vector. The transverse component is r theta dot. That's u sub theta. And then finally, the component, the third component is z dot u sub z, or you can call it k actually, if you like to call it k, because that's actually the z-axis in a way. So this is the radial component, this is the transverse component, and this is the z component. So all we have to do is to figure out each component, and then eventually velocity is a square root of the magnitude of velocity of these three components. Sum of the component squared, take the square root. All right, so VR, which is r dot, it's already given. 1.5, sorry, this is feet per second. I forgot. So r dot is rate of change of r, right? So that would be feet per second. So that's 1.5 feet per second. V sub theta is r theta dot. So we need to do some calculations. So before I going, any further, let's do this, guys. Let's move over here on the side and say, okay, what do we need eventually? We need theta dot, which would be 0.5. And then for the acceleration, we also need theta double dot. You'll see the formulas in a second. So that would be 0. This is based on this equation, right? And then as you can see, z is 4t squared. So we need z dot, which would be 8t. And z double dot would be just 8. So actually at t equal 3, the only one that is a function of time is actually the z dot. So that would be 24 feet per second. Okay, so we are all set. So let's move over here and say, okay, what is v sub theta? That's r theta dot. So r is given to be 3 feet, right? And theta dot is right here, actually, it's 0.5. So that would be 1.5, and look at the unit, by the way. This is feet, this is radians per second, right? So actually it becomes feet radians per second, but remember radian is dimensionless. So that would be 1.5 feet per second. So both, and then I forgot the z dot. So z dot actually happens to be 24 feet per second. So velocity vectorially here would be what? Would be 1.5 u sub r, that's the radial component. 1.5 u sub theta, that's a transverse, and then the other component is 24. So the magnitude of this would be what? The square root of 1.5 squared plus 1.5 squared plus 24 squared, which happens to be about 24.5 feet per second. So that's the velocity of this guy at this instant. Okay? You can actually show how it looks like. You see, it's kind of, I don't have room here to show you the what that velocity looks like, but you just extend the components in the direction 1.5 in radial axis, transverse axis. So remember, this was radial, this was transverse, right? And this is the z. Maybe I can show it to you here. So 1.5, 1.5 positive, and then 24, like that. So kind of, I mean, if we say this is where that point is, point B, point A, where the grip is, right? And I will put our axis there. So this would be the velocity vector, the 24.5. Excuse me. So what about acceleration? Now, acceleration in this coordinate system has the form like this. And you could, again, look at the derivation, look at the formulas. It has a radial component, which happens to be r double dot minus r theta dot squared. That's the radial component times u sub r, plus r theta dot squared plus 2r dot theta dot. That's the transverse component that times u sub theta. And then z double dot u sub z. That's the z component. All right. If we go ahead and we plug in, so this is the radial, this is the transverse, right? And this is the z component of acceleration. So the radial r double dot is what? R double dot is 0. So I'm just plugging into this equation, right? R is given to be 3 feet. Theta dot, remember, was 0.5. Let's see, theta dot was 0.5. That's right. So this becomes minus 1.5. I'm sorry, 0.5 squared, right? Let me just make sure that this is correct. Theta dot was what? Theta dot was 0.5. That's right. So this becomes the r double dot was 0. R is 3, and then theta dot is 0.5. That's right. So this becomes 0.5 squared. So we end up getting minus 3 times 0.25. So that would be, sorry guys, I'm just checking something here, minus 0.75. That would be feet per second squared. Okay. And then a sub theta is r theta double dot, as you can see, plus 2r dot theta dot. Let's see, r is 3, theta double dot is what? 0. So actually the first term is gone. Plus 2 times r dot, which is, r dot was what? 1.5, right? And theta dot is 0.5. So this becomes 3 times 0.5, 1.5. Okay. All right. I just want to make sure that I have everything right here. Yep. Okay. So that would be feet per second squared. And then finally, z double dot, or a sub z is z double dot, right? which is 8, right? It's right here. So here we go. Our acceleration is going to be negative 0.75 u sub r plus 1.5 u sub theta plus 8 u sub z. So the magnitude of acceleration would be square root of minus 0.75 squared, 1.5 squared, and 8 squared. Let me just calculate this for you and see what the outcome is. So we have an 8 squared, a 1.5 squared, and a 0.75 squared. We add them up and we take the square root of that. So let's see, what do we end up getting? About 8.17 feet per second squared. And that would be the acceleration for that particular instant, 3 seconds. Okay, guys, I hope you enjoyed this video. And as usual, I appreciate if you like the video and also join my channel by subscribing. Thank you, and I'll see you soon. And have a good day.